Okay, so the next test portion for 6.2F, exercise 6.2, class 10. These three examples. Sorry, okay. Examples 3, 1, 2, 3. So let us start with example 1. Just follow carefully. This is quite easy, okay. So if a line intersects sides AB and AC of a triangle ABC at D and E respectively, and is parallel to BC, we have to prove that. So triangle is given according to the question. A, B, C. A line is cutting here. The line is cutting at D and E, the two sides. So let us draw that and then write down given. Given is a line intersects AB. Just write AB directly, side. We immediately understand ourselves. SC and AC of triangle ABC at D and E respectively. Okay, then continuing, N is parallel. N is parallel to BC. In other words, DE is parallel to BC. That is given. We have to prove. So write down to prove here AD by AB, AD by AB is equal to AE by AC. So to prove this, let us start. Proof means your answer for this. In triangle ABC, already is given. DE is parallel to BC. As we know, this has been given in a question like that. So if a line is parallel to one side of the triangle, it will cut the two sides in equal ratio. So we can write here AD by DB is equal to AE by AC, since using, or you can also write it, I think this way will be easier, like this by like this, or like this by like this also, it's okay. In this case, I think this will be easier. DB by AD is equal to CE EC by AE, using basic proportionality theorem. So we got that. Now adding 1 to both sides, let us do that. The meaning is DB by AD is added to 1, and right hand side also EC by AE is added to 1. That's allowed, right? If you do that, then you're going to get here DB by simple simplification. AD into 1 is AD. It's a long line because you've multiplied by AD. Then EC plus AE into 1 is AE by here, down here, AE. So that will give you DB plus AD. So DB plus AD is the full line. AB by here, AD, and EC plus AE is full line AC. This plus this is this AC by AE. If you want, you can cross multiply them now. AB into AE, up and down. Then up and down after putting equal sign, up and down, or down and up, whatever. AD into AC. So that now you can get here AE here. So just keep this one same, AE. Where the partner is SC, so bring this SC that side. Then it will go down. Then you didn't touch this AD, so just keep it there. AE is taken, so this one you bring it to right side. Then it will go down. See here now, AE by SC equal to AD by AB. So proved, right? Now example number 2. So example number 2. Page 132. Write it down. ABCD is a trapezium with AB parallel DC. So let's draw that. There is a trapezium, means a figure in which two sides are parallel. These two, let us say. AB is parallel to DC. E and F are midpoints of are points on non-parallel sides. Trapezium means one pair is parallel and the other is not parallel. So D is point on one side, E is the other point on the two non-parallel sides. So let's join them. Then we have to prove something. So let us just write down given. Given is ABCD is a trapezium. Okay, trap. In short, you can write like that with AB parallel to DC. E and F are points on. E and F are points on non-parallel sides. On non-parallel sides, AD and BC respectively. AD and BC respectively. That means E is on AD and F is on BC. That means the meaning of respectively. Such that EF is already given parallel to AB. So here AB parallel DC, EF parallel. Basically these two are given. With this we have to prove something. Let us do that slowly. To prove here AE by ED. Okay, AE. E and F, sorry, not D and E. E and F, please correct it. You can see here. So AE by ED, we have to prove AE by ED is equal to BF by FC. BF by SC. So this is what you have to prove. Let's do the construction. One simple construction will help us to do this. And let's just join this. Join AC. Let us say intersecting. Intersecting the line EF at, let us say, G. Any letter you can use actually. ST also. Because I'm just using G because F was the last letter used here. So F and G. So that is construction. So now let us start the proof. Means your answer for this. In triangle ADC. Let us take this one first. ADC. Okay, in triangle ADC. Let me write like this. Okay. AB parallel to DC. Because it is given. And also, not only that, EF parallel to AB or AB parallel to EF, whatever. You can see here, AB parallel to EF. So if two different lines are parallel to the same line AB, those two lines will themselves be parallel. So EF will be parallel to DC. In other words, we can write here EF can be shortened and write EG. Because EG is part of the same straight line as EF parallel to DC. So if EG is parallel to DC in this triangle ADC, we can use basic proportionality theorem. AE by ED is equal to AG by GC. AG by, and we can write just since using basic proportionality theorem. Okay. Let's just keep this one as equation number 1. Then in the other triangle, let's take this ABC. So here, let us write down EF parallel to AB is given. Already you can see here EF parallel to AB. So this EF can be shortened as GF. Okay, that is GF parallel to AB inside this triangle now. GF parallel to AB means this line is parallel to one side. So we can just write here, okay, AG by this one GC. We can write like that also. Down by up, so here also down by up, BF by FC. And the reason for this is same as basic above theorem here. So I'm just writing the do. So we can proceed and do here. These two are same now. AG by GC can be replaced by this one, therefore AE by ED will be equal to BF by FC. So proved. You see, that's what the question is asking, right? So we can do like that. Now one more question before we end example 3. Then after that you can give the test. Example 3, page 132. The figure PS by SQ equal to PT by TR, angle PST equal to PRQ, proof PQR is isosceles triangle. So there is a triangle given to us like this, given figure. As you can see in the textbook, for this question the figure would be on the question paper itself. So here there is a line ST, given that this PST equal to PRQ. So these two are equal, it's given. So given to us here, do slowly, in the figure, okay, in the figure, PS by SQ is equal to PT by TR, PT by TR, this is given. And one more information, angle PST is equal to angle PRQ, angle PRQ. We have to prove something, so let's just write down to prove triangle PQR, this triangle is isosceles. Now we know that the definition for isosceles triangle is out of the 3 sides, 2 sides must be equal. So we're basically trying to prove that these 2 sides of this triangle are equal, then that is isosceles. We're trying to prove that. So how do we go about doing that? Well, let us do that. Here proof means your answer for this. Let us say proof. Then here, just going to write this one. Angle PST is equal to angle PRQ given already. So we write here, given to us, let us say question number 1. Now here, I'm going to write next here in triangle PQR, the big one, the full triangle. This is given, PS by SQ is equal to PT by TR is also given. So next here, that is, if this PS by this SQ equal to PT by TR, in other words, this line ST divides this side PQ and the side PR in the same ratio, in this equal ratio. Otherwise, this equation is coming out like this, means this line is dividing this side and this side in equal ratio, means this by this equal to this by this, means in the same ratio. So we know that if it is like that, a line is dividing 2 sides of a triangle in same ratio, then that line is parallel to the third side. And we know this theorem we discussed previously also. It is known as using converse of basic proportionality theorem. Okay, so if ST is parallel to QR, that will help us here. These two angles now, PST angle, PST will be equal to angle PQR because they are corresponding angles. If 2 lines are parallel, then the corresponding angles are always equal. So now we can write here that implies angle PST equal to, okay, PST is here, same, you can replace this one now by this one, PRQ equal to this one remains same, PQR, and we can write here since using equation number 1. So now if these two angles are equal, then in, you can keep this one as equation number 2 if you want, then finally you can write here in triangle PQR we have established just now PRQ equal to angle PQR as we see from using equation number 2. So we know that in our class 9 also we've done this. Okay, this class 9. So in a triangle, if two angles are equal, PQR equal to PRQ, then the sides opposite to these two angles will be equal. So what is the side opposite to PRQ? PRQ is this, so the side very far away is the opposite, is this one, PQ. Side, that one, and PQR, angle PQR. These are the two arms. The one which is not the arm is the opposite side, so PR. These two opposite sides will be equal because we know that sides opposite to equal angles, that means two equal angles in a triangle are always equal to each other. The sides which are opposite to the two equal angles are always equal. This is a theorem, right? So PQ equal to PR means two sides of this triangle are equal. That means if two sides of a triangle are equal, therefore the triangle PQR is isosceles, because definition for isosceles is if we can prove two sides are equal, that is isosceles. So this ends the portion for test. Okay, now you can go and give the test. Fine.